Hi, this is I am going to prepare a demo video of the topic Gravitation of Class 9, Chapter 10. Thank you, Baizus, for giving me this opportunity to make the demo video. Let's start the topic of gravitation. So, what is gravitation? We know that every object in this universe has mass. From the elementary particles, atom, to the celestial object in this universe have masses, all have masses. So, in a small sense, we take an example. Say, this is a mass M, and this is our Earth. Earth have also mass, and we place it at a certain height, x. If we release this mass, it will goes towards our Earth. So, Earth is attract this mass. So this force between this mass and this mass is called gravitation. If it goes beyond our Earth is moving around our sun, and all the planets, 8 planets are moving around sun, and also the satellites are moving around its own planets, and also the sun is also moving around some galactic orbit, galactic center. So all have some force of attraction. This force of attraction we can call gravitational force. Okay, so if any object have mass, there is a force. This force is called gravitational force. And also we can call a force gravity force. This is force for our Earth. All the objects around our Earth and our moon is attracted by our Earth. So this force is called gravity. The force of gravity and force of gravitation. Gravitational force is the force among the masses of our universe, and the gravity force is the force between our mass, our Earth, and the masses around our Earth. So Newton proposed a law which we can call universal law of gravitation, or Newton's law of gravitation. First, we have to know what is the statement of this law. Newton said that every object in this universe attracts each other by a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Say we consider two masses, mass m1 and mass say m2. These are the centers of these masses, and if we draw a line between these two masses, we will get the separation between these two masses. This is the separation or distance between these two masses. So if we consider this mass is Earth and this mass is say Sun, they are both giving some force. This Earth attract by a force of Sun, and Sun also attract our Earth. So this force is directly proportional to the product of their masses, mass m1 and mass m2, and inversely proportional to the square of the distance between them. This is the distance. If we write, this is equation 1, this is equation 2. If we write, by combining these two equations, equation 1 and equation 2, we get F is proportional to m1 m2 divided by d square. If we replace this proportionality sign by a constant which we can call gravitational constant, then we get this equation. F is equal to g m1 m2 by d square. G is gravitational constant or universal gravitational constant, and we have values 6.67 into 10 to the power minus 11 Newton meter square kg inverse 2. This is the unit of gravitational constant. Okay. we take an example, say mass m1 is 1 kg and mass 2 is 1 kg, and this is the separation, say D. So the force between these two masses is directly proportional to the masses. So what will be the force? Mass m1 and mass 1 kg and 1 kg multiplied by 1 kg, then the force will be 1 Newton. If we increase the masses, say 2 kg and 2 kg, then product will be 4 kg. So the force will increase if we increase the masses, and if we increase the distance, say D is 1 meter, so force will be 1 by D square. So 1 divided by 1 square, it will be 1 Newton. If we now increase the distance, say distance is 2 meter, now force will reduce to 4 times. 1 by 4 means it will reduce to 4 times. If we increase the distance to 3 times, then force will reduce 9 times. Okay, so this is the universal law of gravitation and gravity force. Okay, gravity force is for our earth and gravitational force is for the masses present in our universe. Okay, thank you.